Dear children, now we can study a new lesson, fourth lesson, linear equations in two variables. You know what a linear equation in one variable and also know how to solve it. Also we know the standard form of the linear equation in one variable. How can we frame a linear equation in one variable from a given statement? We can convert a statement into linear equation in one variable. Reverse also, conversely, a statement an equation can also be converted into a statement. For example, x plus 5 is equal to 7 is a linear equation in one variable. Why? Because here we have only one variable in the equation, x, and its exponent or degree is 1. So, equations of this form is called a linear equation in one variable. How can you solve this? X equal to 7 minus 5 is equal to 2. How many solutions are there for a linear equation in one variable? It has only one variable. So, a unique solution, one and only one solution for this equation. What is the statement form of this equation? 5 is added to a number gives 7. 5 is added to a number gives 7. 5 is added to a number gives 7 is the statement form of this equation. Here a number is unknown. Or another form, sum of a number and 5 gives us 7. Sum of a number and 5. Sum of a number and 5 gives us 7. What is the number? So such a statement can also be written in the form x plus 5 equal to 7. 3 subtracted from a number gives 8 is a statement. How can you convert this statement into equation? 3 subtracted from a number. Let the number, unknown number, be x. X minus 3 gives us 5. X minus 3 equal to 8. 3 subtracted from a number gives 8. That is x minus 3 equal to 8 is the linear equation. From we can convert the statement. Convert this statement. 3 subtracted from a number gives 8. Can be converted into the form x minus 3. This is a statement form. This is the form of equation, linear equation in one variable. And we know that it has only one solution because it has only one variable. So, what we also know that the standard form of a linear equation in one variable. There is a what are the features of this equation? A term containing x or y variable and a constant term equal to any number. In general, we can say that ax plus b equal to 0 is the standard form of a linear equation in one variable. Ax plus b equal to 0. A term containing x, b, a constant term equal to 0, where a not equal to 0. We have to apply this condition also. What happens if a equal to 0? This becomes a 0 into x plus b equal to 0 means b equal to 0 or b equal to 0. Only when b equal to 0 we get a b equal to 0 is true. Otherwise, if suppose in this case suppose x plus 5 equal to 0. See, if 0 x plus 5 equal to 0, it means 5 equal to 0. This is not true. So we must put a condition in the general form. Ax plus b equal to 0. Where a is the coefficient of x, that cannot be 0. But b can be 0. If b equal to 0, suppose what do we get? X plus 0 equal to 0. That is x equal to 0. This is also a linear equation in one variable, and the solution is x equal to 0. Here coefficient of x is 1, not a 0, but b is equal to 0. B can be 0. B is not equal to 0. Now, to solve and how many solutions are there for a linear equation in one variable. Now in this lesson, we are going to learn linear equations in two variables. Linear equations in two variables. In linear equation in one variable, we consider only one variable, say x. But a linear equation in two variable contains two variables, say x and y. X and y. Then how will you frame a linear equation, or what are the situations in which we form a linear equation or linear equations in two variables? For example, the sum of, consider this statement, the sum of two numbers is 5. The sum of two numbers is 5. What are the numbers? What are the numbers? If 5 is added to a certain number, we get 8. There is only one variable. Unknown is 1. A number added to 5. A number, only one number. So let us convert it as an equation in the form x plus 5 equal to 8. Here, the sum of two numbers is 5. What are the numbers? So one variable is not sufficient. We consider two variables, say x and y. To sum of two numbers. Let the first number x. Second number y. Then what is the form of another form, or how can we convert this into form of an equation? X plus y equal to 5. X plus y equal to 5. This is a linear equation in two variables because each variable has degree 1, first degree, x raised to 1, y raised to 1. But this contains two variables, x plus y equal to 5. Then 2x plus 3y equal to 7 is also a linear equation in two variables. Linear equation in two variables. 2x plus y equal to 2x plus 3y is equal to 7. 4x equal to 5. Is this a linear equation in two variables? It is a linear equation in one variable, but we can convert this into a linear equation in two variables in this manner. 4x plus 0y equal to 5. See, 4x plus 0y equal to 5. Then y equal to 7 is a linear equation in one variable, but we can convert this into a linear equation in two variables in this manner. 0x plus 1y equal to 7. See, two variables, but the coefficient of x is 0. Here coefficient of y equal to 0. So a linear equation in one variable can also be converted into a linear equation in two variables. So, but in that case, if one variable is there, we can write the other variable with the coefficient 0. The coefficient 0 means 0 into y equal to 0 means 4x equal to 5. Now, what can be the standard form of a linear equation in two variables. A term containing x, a term containing y, a constant term. Or this can also be written as 2x plus 3y minus 7 equal to 0 by transposing constant term to the LHS. Here this can also be written as x plus y minus 5 equal to 0. Here this 4x plus 0y equal to 5 can be written as 4x plus 0y minus 5 equal to 0. This can also be written as 0x plus 1y minus 7 equal to 0. So what are the features of a linear equation in two variables? There is a term containing x, there is a term containing y, then a constant term. So in general, we can write ax plus by plus c equal to 0 is the standard form of a linear equation in two variables. Or any equations of this form, any equation of this form is called a linear equation in one variable. In linear equation, two variables. In linear equation in one variable, we put a condition. Coefficient of x is never 0. Here also, ax plus by plus c equal to 0. Look at this equation. B can be 0. 4x plus 0 by minus 5 equal to 0. B can be 0. Look at this equation. A can be 0. So, A can be 0, B can be 0. But at the same time, if both A and B 0, what happens? This equation becomes 0x plus 0y plus c equal to 0. Means there does not exist x or there does not exist y. That means if both A and 0, A and B are zeros, then there does not exist an equation in two variables. So we have to put a condition here that A and B, both A and B are zeros. Both A and B are zeros. Either A can be 0, then B not equal to 0. Or if A not equal to 0, then B can be 0. C can be any number, 0 or not. For example, 0x plus 0y plus 7 equal to 0. This is not a linear equation in one variable. Two variables. By 0x, no term containing x. 0y, no term containing y. Then we get a 7 equal to 0. Actually, this is not true. When do we get this term equal to 0? If this is also 0. But if A equal to 0, 0x plus 6y plus 7 equal to 0. What happens? This term is not there, 6y plus 7 equal to 0. It is also a linear equation. In one variable can be converted into a linear equation in two variables. Then 5x plus 0y minus 5 equal to 0. Here there is no term containing y, but then 5x minus 5 equal to 0. That means this is also a linear equation in two variables. Though it contains only one variable, we can convert this into a linear equation in two variables. In general, ax plus by plus c equal to 0, where both a and b are zeros. Both a and b are not zeros. Represents a general linear equation in two variables. Ax plus by plus c equal to 0. Now 3x or first equation, x plus y equal to 7. Actually the form is x plus y minus 7 equal to 0. What is the coefficient of x here? 1. Coefficient of y? 1. That is both a and b are not zeros. At the same time, or equal to 7, or x plus y minus 7 equal to 0. Now we know how to solve a linear equation in one variable. Ax plus b equal to 0, ax equal to minus b, x equal to minus b by a. Unique solution. So how can we solve a linear equation in two variables in this manner or any other way? Here, what is the statement form of this? The sum of two numbers is 7. Suppose x equal to 0. What is the value of y to get to 7? Y equal to 7. 0 plus 7 equal to 7. If x equal to 1, what is the value of y? Y equal to 6. 1 plus 6 equal to 7. If x equal to 2, y equal to 5. If x equal to minus 1, y equal to 8. Y equal to 8. That is 8 minus 1 equal to 7. X equal to minus 2. Y equal to 9. X equal to minus 3. Y equal to 10. And so on. Here in the form x plus 3 equal to 5. X equal to 5 minus 3 equal to 2. X has only one value. That means a linear equation in one variable has a unique solution, one and only one solution, the number which makes the given equation true. But here see, x can take different values. We get corresponding values of y. That means x equal to 0, y equal to 7, 0, 7. What are the 0, 7? X 0, y 7 is a solution of this equation. What is another solution? 1, 6, 2, 5, minus 1, 8, minus 2, 9, minus 3, 10. In this way, how many solutions are there? How many solutions you can write there? Many solutions. Many solutions. That means a linear equation in two variables has infinitely many solutions. Infinitely many solutions. If we take a value for x, we get a corresponding value of y. If we take a value for y, we get a corresponding value of x. In that way, we get it. That means, but a linear equation in one variable has a unique solution. A linear equation two variables has infinitely many solutions. Infinitely many solutions. No unique solution. For every value of x, we get a corresponding value of y. That makes the equation true. Or for every value of y, we get a corresponding value of x, which makes the equation true. Or both the values make the equation true. So the standard form of a linear equation in two variables, ax plus by plus c equal to 0. And at the same, both a and b cannot be 0. Both a and b cannot be 0. C can be 0. Either a can be 0, b not equal to 0. B can be 0, a not equal to 0. These are the cases. And we know, now we have seen how to solve this type of equations. Equations in two variables has infinitely many solutions, whereas equation in one variable has a unique solution. Now, you have to read the textbook pages 66 to 70 and do the examples 1, 2, 3 and 4. Also do the questions, exercise 4.1 and 4.2, all questions. Thank you.